Good morning, myself Prasanta Samal, and you are watching the academic channel of Prasanta Institute of Technology. So today I will discuss about the subject of energy conversion, and the topic is alternators. So before we discuss alternator, let me tell you what is AC system and why it is very important. Now AC system plays a very important role in generation, transmission and distribution, and with the help of transformer it is very easy to transfer the voltage from high value to low value or low value to high value. So now what is alternator? Alternator is an electrical machine which converts the mechanical energy into three-phase electrical energy. So we are considering here a three-phase alternator, and in this case the principle of operation of alternator is electromagnetic inductions. So what is the principle of electromagnetic induction? Whenever there is any change in flux linkage in a conductor, an EMF is induced in the conductor, and the operating principle of alternator is Faraday's laws of electromagnetic induction. And generally in alternator, the armature winding is stationary while the field system is rotating. But in a DC generator, the field system remains stationary and the armature is rotating. But in an alternator, the reverse is there, that is, the armature remains stationary and the field system is rotating. So what is the advantages? What is the advantages of stationary armature and rotating field system? So here are the advantages. The first advantage is that it is very easy to insulate the slip rings. It is very easy to insulate the stationary winding for high voltage. So in high voltage, it is very easy to insulate the stationary winding, while it is very difficult for us to insulate the rotating parts. And second advantage is that the stationary three-phase armature can be directly connected to load without the use of brushes and slip rings. And third advantage is that only two slip rings are required for a DC supply to the rotor winding. And the fourth advantage is that due to simple and robust construction of the rotor, higher speed can be possible. So alternator is a double-fed machine and it has two inputs. One is the mechanical energy which is given by the prime mover, and second is the DC supply which is given to the rotor field winding. Next is the construction of alternator. Construction of alternator. So alternator has mainly two parts. One is the starter and another is the rotor. Now first we discuss what is starter. The starter is the stationary part of alternator in which three-phase armature winding is placed, and generally the stationary windings which is placed in the starter are star connected, and it is star connected armature are connected in starter winding. Why star connection armature winding is connected in star connection? So there is a relation VPH is equal to VL by root 3. So in this relation already you know that in star connection phase voltage is equal to line voltage by root 3. So when the starter winding or armature winding is star connected, then less number of turns of armature winding is required. Whereas if the armature winding is delta connected, then more number of turns will be required. And that is why the armature winding is star connected, and also it permits the use of protective device against the ground faults. So this is all about the starter. Then coming to rotor, actually alternator is classified on the basis of construction of rotors, and the rotor is classified into two types. One is the salient pole type rotor and another is the non-salient So rotor is alternator is classified on the basis of construction of rotor, and rotor is classified that is a silent pole type rotor and non-silent pole type rotor. And in today's class, we only discussed about the silent pole type rotors. So you see, this is a 4-pole silent pole type rotor. In silent pole type rotors, silent means projectiles. What is the meaning of silent? Silent pole means projectile pole. So in this case, silent poles are connected to the large circular steel frame, and in this case, field windings is connected to the poles, and the field windings are connected in such a way that when a DC supply is given, then the adjacent poles become opposite. So when a DC supply is given, the adjacent poles become opposite. So opposite pole is necessary to produce or to induce the alternating EMF. So in this case, in silent pole type rotor is generally used in hydroelectric power plant where less speed is required. So in this case, the speed is almost 120 to 400 RPM. 120 to 400 RPM speed is required. The 120 to 400 RPM speed is possible in silent pole type rotor. It is because of a fixed relation. Already we know that there is a speed relation ns is equal to 120 f by p, and in this relation the value of frequency f is equal to nsp by 120. So you see in this relation, since the diameter of the circular frame is large, therefore we have to accommodate large number of poles. So in this case, the number of poles is large. So since the number of poles is large, therefore the speed must be less. So that the speed must be less, so that a desired frequency of 50 Hz. So that the desired frequency of 50 Hz of induced voltage is possible, and that is why the speed of an silent pole type rotor is in the range of 120 to 400 RPM, and it is generally used in hydroelectric power plant, and it has a large diameter. This rotor has a large diameter and small axial length. And to know more about the non-silent pole type rotor and the remaining part of alternator, you have to come to the next video. Thank you. Thank you very much.